Welcome to the Google Cloud Platform Education Series. My name is Jeff Davis, and in this session, we'll discuss building high-performance, scalable VM environments on Google Compute Engine. We'll be doing a moderated Q&A throughout the session, so feel free to submit your questions with the Ask Your Question Here field at the bottom of your screen. Let's get started. Here's our agenda. We're going to begin with an in-depth demo where we build the necessary infrastructure to support a fairly sophisticated application. This will illustrate all of the key features within GCE and give you an idea of how quickly and how easily you can build a robust, scalable, high-performing infrastructure. We'll then go ahead and talk about the wide range of GCE features, giving more details on the features that we demonstrated and talking about some other capabilities that may be useful in your applications for your particular use cases. I'll spend a few minutes describing how best to find information as you're doing research after today's session and you're exploring GCE on your own. We'll talk about strategies for determining how well GCE applies to particular challenges or particular computing workloads that you're looking to move into the cloud. And as I mentioned, we'll be doing a rolling Q&A, so feel free to keep those questions coming. So let's dive into a demo. So we're going to start with an application run by a company called betterdev.io. This is the BDev squared system. It's a learning management system that allows employees all around the world to find useful tidbits provided by other developers and get up to speed on the newest technologies. You can see down here that you can easily take a look at existing learning paths. This information is pulled from a database of plans or playlists of modules that developers would find interesting on particular topics. You can find individual modules. So for instance, here's a series of modules on how to teach the newest Google Cloud Platform class, as well as something about mantas, which we'll look at in just a moment. You can also look at your learning activity and your accomplishments and where you are in your performance against various plans. So if you click through to one of the modules, you can see that it's a small micro learning nugget. It has some text and it has, most importantly, a video segment. These modules are created by BetterDev employees and they're shared with other BetterDev employees, and then they're put together into learning plans or learning paths that people can follow. If you want to add a new module, you simply enter the title. So I like mantas, and I'm the author, and mantas, mantas, mantas. And then you can choose to upload a video file. What this will do is actually upload the file to a backend and then create a new module record in the database. And this module will then be available to learners throughout BetterDev. You can see that the new module has appeared here. And if you click on any module again, it shows you something about mantas, for instance. Okay? Now, some considerations when we are running this learning management system. We have BetterDev employees all around the world. And so we want them to have a good experience, whether they're coming from Asia or from Europe or from North America. We want the performance to be good. Additionally, we want the video to stream well, regardless of your network connection or your device. So those videos that we upload, they may start as 4K or 1080p videos, but we're going to want to transcode them into various sizes so that we can do adaptive streaming on the fly. So let's take a look at the architecture behind this, and then we'll actually show you how to build it from scratch. So here's the architecture. We have users coming from North America, from Europe, and from Asia. They all hit a single IP address, and this IP address is actually an intelligent load balancer. It will direct users to the closest set of servers that have capacity. So you'll notice that we have servers in US Central, in EMEA West, and in Asia East. We're running Nginx servers here, and these servers deliver the standard user interface to the LMS users. If load goes up, we want this to actually scale and give us multiple servers automatically. These servers are pulling all of the configuration data, the user information, the information about the learning paths, the information about the learning modules out of a Cloud SQL instance. When you create a new module, you upload media, and that media goes into Google Cloud Storage. And as I said before, we want to transcode that media. So we want to actually take the original video file and we want to encode it at 480p, 720p, and 1080p. So once you dump it in cloud storage, we have transcoding servers. These are backend servers separate from the front-end servers running Nginx. And these transcoding servers will open up the submitted file, transcode it into different versions, and store it in a different location. Let's take a look at how to build this actually in Compute Engine. So if we switch over to my list of VMs in Compute Engine, you can see that I have a single backend instance that is currently running. This is the server that watches for new media files to be submitted, automatically grabs those files and transcodes them and stores them in a Google Cloud Storage bucket. I also then have front-end instances, and you can see that I've got 3 front-end instances. I have 1 in each of the regions. I have Asia, Europe, and US West. So traffic will get directed to each of these regions based on where the traffic originates and whether or not the target region has sufficient capacity to serve the additional requests. I have a network load balancer. So if I go to the networking section, you can see that there is a single load balancer that is configured. This load balancer provides the IP address that we're hitting that then directs users to the closest available resource. We have Google Cloud Storage set up, and you can see that we have raw media. These are the files that are submitted by developers who are creating modules to share with their peers. And then we have another bucket here, and this bucket contains transcoded video files. These are, for instance, the 480p, the 720p, and the 1080p versions of videos that have been uploaded by module creators. There's also a Cloud SQL instance, and this is the database that is containing all of the user learning path and learning module information. So let's test, before we take this all apart and try to build it again from scratch, let's test the load distribution, sort of the geographic routing of traffic, and let's test the auto scaling. So what I'm going to do is I'm going to bring up 3 test machines. I have a machine in Asia Pacific, a machine in EMEA, and a machine in the US. I am going to SSH into each one of these in turn. And I'm going to do a little load generation on each one. Let's see. Shrink this one over here. So you can see that I've got 3 SSH sessions. I'll make this a little bigger so that everybody can see it. Okay. Now again, the site that we're going to is the site represented by this IP address. So I'm going to grab that IP address and let's do something simple. Let's use Apache Bench. We're going to do 5,000 requests. We're going to have 1 simultaneous session, and we're going to just pull the home page. And I want to take that command and I want to run it in 3 different locations. I want to run it in Asia Pacific, I want to run it in the US, and I want to run it in EMEA. Now we also want to see the effect that this load generation has. So what we're going to do is we're going to look at our backend service configuration. And this will give us a nice little chart that shows us how traffic is getting routed. This shows us the origination region of the traffic, and this shows us what backend the traffic is getting routed to. Okay? So with that, what we'll do is we'll kick off the traffic sessions on each one of these. And then we will go back to Backend Services. And what we should see here, now this is a graphical representation that tells you about the health of your backends as well as the traffic that's being directed to them. This doesn't really update in real time, so I'm going to sort of force it to refresh here. But when we're done, what we should see is traffic originating from 3 different geographic regions, and the traffic is getting routed to servers also in those regions. Voila. So you can see that we've got requests coming from Asia going to Asia, we've got requests coming from North America going to North America, and we've got requests coming from Europe going to Europe. You'll notice that we're already actually reaching the maximum utilization that I've set on these instance groups, so that really we don't want servers handling more than 50 requests per second, and this is handling 67. This is handling 55. So what should also happen here is we should see some auto scaling. So the instance groups will actually add servers to deal with the additional capacity requests. So I'm going to refresh my browser in hopes that I can actually get, you can see for instance, Asia has now scaled up to 3 instances. You can see that North America and EMEA are scaling up to 4. This says that there are instances that are unhealthy. This is probably just because they're still spinning up and they haven't started handling requests yet. If we go back to Compute Engine and we go to instance groups, you can look at the instance groups and you can see that they're scaling up currently. So for instance, if I look at Asia, I can see that I'm averaging about 20% CPU utilization across all of the instances, and that there are 3 live instances responding to load. If I go to EMEA, we should see that I'm now actually up to 4 instances handling the load. And again, this has kept the CPU utilization on average down to around 20%. So that's pretty cool. What we have is a situation where increased traffic drives automatic scaling of my instances, and the traffic gets routed to the nearest instance group that has capacity. You'll notice most of the stuff from Asia goes directly to Asia. Occasionally, there may be requests where the Asia cluster is determined to not have enough capacity, so it automatically routes it to the next lowest cost network path, which in this case would be Europe. So that shows scaling of the front end. Let's take a quick look at scaling on the back end. Okay, so to check out scaling on the back end, what we need to do is we need to create several new modules and upload new videos. The video transcoding will eat all of the CPU for a backend server. So if we do multiple uploads, we're going to need multiple backend servers to do the transcoding. So the instance group that we want to look at here is actually the backend group, and we're going to look at it by CPU utilization. And let's add a couple of additional modules. Here's a demo module, and I'm going to pick a video file and upload that. And I'm going to create another module, and this will be demo 2. And we'll pick another video file, and we can do one more. Demo 3. Okay, so now what we've done is we've uploaded 3 new video files, each of which needs to be transcoded. Okay, and you can see here's the first module. If I click on this, this will actually take me to a learning module that has an embedded video. This is the raw 1080p video though. On the back end, what we want to have happen is we want the transcoding to occur. If we look in the bucket behind the scenes, what you'll see is there's the chapter 1, 2, and 3 videos. And we want to have more new transcoded sessions appear here. So you'll notice that this is my backend instance group. And you can see now, instead of having one instance, there are 3 instances. And you can see that the average CPU utilization is on the order of 80%, 75, 80%. And so what this has done is every time I upload a new module that contains a video, a message goes to the backend servers. The backend servers kick off the transcoding sessions. The transcoding sessions shoot the CPU utilization through the roof. Because I've set a limit on the amount of CPU utilization I'm comfortable taking on, when I go above 60% CPU utilization, it spins up another instance, and that then pulls the next video for transcoding out of the bucket. And so this whole thing is working for us. Now, that looks great. You say, Jeff, terrific. How hard is this to build? Were you up till 4 a.m. this morning putting this all together? And the answer is maybe, but you won't have to be. It's actually quite straightforward. So what we're going to do is we're going to start with 2 bases. What I've got is a back-end base and a front-end base. And these are simply standard Debian images onto which I have installed some software. I could do that all from scratch now, but it takes a little bit of time to set those up. What I'm going to do, though, is I am going to take each of these pre-configured virtual machines, and I am going to create a base image from them. So you can see I don't want to delete the boot disk when I delete the instance. I'm going to check each of those to make sure that that's the case. Okay. So what we're going to do then is these 2 base images that are configured to work just the way I want. What I'm going to do now is I'm going to delete them, but I will keep their boot disks. You always start this recipe with a pre-configured machine that works the way you want it to. Then what you can do is create a boot disk image. So I'm going to create a new image, and I'm going to call this demo front end. And you pick a source. In this case is an existing disk. This is a disk that I took off of a functioning VM. And I'm going to pick the FE base, and I'm going to create a new disk image. Now I'm doing this all through the GUI. You can just as easily do this from the command line, or you can script it, or you can write custom management tools that will automate this entire process for you if you like. So while that's creating the front end image, I'm also going to create a back end image. And I'm going to call this demo backend. And again, it's going to start with a disk. And I'm going to go to the LMS backend base. And I'm going to create that image. So when I'm done, I should have 2 new boot disk images created from the disks on 2 functioning VM instances. Once we get that up and running, let me refresh this. You can see that my 2 images are being created. Once I have these images, I can then create new VM instances that look just like the original development machines that I was working on. And that's great, but I don't want to just build them one at a time. I actually want to have Google Compute Engine automatically create these instances and be able to scale up the number of instances or scale down the number of instances for me automatically. So to do that, I need to create what's called an instance template. So there's my first image done. My second image is finishing up. So I'm going to go to instance templates, and I'm going to create a new instance template, and we'll call this demo front end template. And I'm going to pick a standard machine configuration, so 1 virtual CPU and 3.7 gigabytes of memory. I'm not going to do a clean Debian install. Instead, I'm going to pick a custom image, and this is going to be my demo front end image. And I'm going to designate the scopes available. So when you boot up a VM, you can designate whether it has access to certain APIs. We're going to go ahead and set that and say, you know what, I need access to PubSub, I need access to Cloud SQL. I need access to Compute Engine. And I need access to storage. So where's Compute Engine? There we go. So I set the scopes. And what this is basically saying is anytime I boot up an instance based on this template, I want to make sure that it's using this boot image. I want to make sure it's this machine type. And I want to make sure that it has access to these APIs. So I'm going to go ahead and create the template. And then I need to similarly create a backend template. Now the backend template requires a little bit more configuration. I need to actually grab a startup script. So I'm going to look at one of the existing instances. And I am going to go find the startup script. So you can see here, this is the script that runs when the backend instance server boots up. So I'm going to go ahead and create an instance template. And this one is going to be for the backend, so we'll call it demo backend template. Same machine configuration. Again, I'm not going to use a standard image. I'm going to use a custom image. It's the demo backend. And again, I need to specify what scopes it's using. And it's going to be using Cloud Pub Sub, and it's going to be using the Compute Engine API. And it's going to be using the Cloud Storage API. And then I'm going to specify which startup script it runs when it boots. And we'll create that. So what we've done is we took stock VMs and we added our applications. And that created newly configured VMs. We took those VMs, we copied their disks and made images. We took those images and now we've made templates. From the templates, we're going to make instance groups. So I'm going to create a new instance group. And an instance group is a collection of VMs that you can manage together. And if they're based on a template, you can set up auto scaling and load balancing quite easily. So we're going to do demo front end North America. And I'm going to put these all in the West zone. And I'm going to use an instance template. This is going to be the front end template. And I'm going to turn auto scaling on. And I want auto scaling to be based on HTTP load balancing usage. And I want to set a minimum of 1 instance running and up to 5 instances running. Okay, so that is my, well, actually we'll come back and we'll do the load balancing in just a second. We'll start with CPU usage. We'll create this instance group. Now, for the front ends, remember we had them globally distributed. So I'm going to create, I'll just create one more. And this will be demo front end EMEA. And I'm going to set this to run in Europe. There we go. And again, I'm going to use the same template. And I'm going to set auto scaling on. And this is going to go from 1 to 5. And we'll create that. So now I've created 2 instance groups. One for the front end in North America, one for the front end in EMEA, and I need to create one more, which is for the back end. So this will be demo backend. We'll just call that demo backend group. And we're going to put that in US West. And we're going to use the demo backend template. We're going to set auto scaling on based on CPU utilization from 1 to 5. We're going to create that. So now what we have is we have an instance group for the back end, and that runs in North America. And we have 2 instance groups for the front ends, one in North America and one in EMEA. If you look at the VMs, what you'll see is we have 1 instance for the front end in EMEA, 1 instance for the front end in North America, and 1 instance spinning up for the back end that's also running in North America. So you can filter here and you can see these are the 3 instances that are currently running. Again, these are auto scaling instance groups, so they can go up to 5 instances per, but because there's no load on them currently, there's only 1 running in each group. Now, the next thing that we need to do is set up the load balancer, right? This is the single IP address that's going to send traffic intelligently to the right backend, depending on where the request originates. So in order to do that, what we're going to do is switch over to networking. And in networking, I am going to click load balancing, and I'm going to create a new load balancer. Notice there are 3 types of load balancers. I'm going to pick an HTTP load balancer. You start by giving it a name. So this is going to be demo load balancer. You configure a backend service. And to be clear, this is a backend load balancing service. This is not the backend service for my application. So I'm going to create the backend service, and I'm going to call this demo front end load balancing. And I'm going to pick the North American front end instance group. I'm going to say if I'm at 30% CPU, or if I'm at 80% CPU utilization or 30 requests per second, then consider this group of servers to be over capacity. And then I'm going to do the same thing for Europe. And let's see, I don't need that. And then I need to set a health check, and the health check is going to be the front end health check. So now my back end service for the load balancer is set up. My host path and rules I don't need to set. My front end configuration, this is going to be an HTTP load balancer, and it's going to use ephemeral ports, and I can go ahead then and create the load balancer. So while this spins up in the background, we're going to cross our fingers and hope that when we're done, we click on the IP address for the load balancer. It's going to automatically determine which back-end group of servers to send us to. We're going to go to that back-end group of servers, and one of those servers will respond, and if we generate load, the server instance groups should automatically scale for us. So let's take a look. So we cross our fingers and hope that this actually is going to work. Here's our global load balancing pointing at our backend instance groups for the demo. That's what we just created. We click on this, and I'll be darned, look at that. We can see that this is actually being served by a demo front end server, and it's being served out of the US West 1A zone, and it has access to all of the same information that the previous incarnation of the application was using, because it's talking to the same SQL instance in the background. If I want to generate some load, let's say I want to generate 5,000 sessions with 50 simultaneous sessions. I'm going to do that, and I can do the same thing in EMEA. And hopefully what we'll see is that this generates traffic across our backend servers. So let's go to Backend Services. We can see that this is the previous backend service that we had configured for the original application. This is our demo application. And if we click on this, what we should see is traffic going to, again, we need to wait for it to sort of update. But we do see traffic going from being originated in North America and in Europe, and over time the visualization should get cleaned up, and you should actually see some of this going to Europe. Let's take a look at the instance groups real quick and see how they're doing. So we have the demo instance groups. They are all at 1 currently. They haven't needed to auto scale yet, but they will auto scale as necessary. So in the course of about 5 to 7 minutes, we were able to essentially replicate the same sort of configuration that we started with by creating images from good virtual machines, taking the images and creating instance templates, taking the instance templates, creating instance groups, and then front-ending that with a network load balancer. Okay? And that gives us the configuration that we talked about in the architecture slide. So a lot of details coming at you real fast, but hopefully that gives you an idea of the range of capabilities and just how easy it is to build high-performing, scalable, globally distributed applications on top of Compute Engine. Let's take a step back and make sure that we can put all of those individual examples in context and look at Compute Engine's overall functionality. So by now it should be clear that Compute Engine is a product that allows you to run virtual machines atop of Google's massive infrastructure. So tons and tons of computing cores, of memory, of disk storage, and of network, globally distributed. And a tooling and workflow that allows you to easily spin up 1 to hundreds to thousands to tens of thousands of VMs and coordinate their activity, and also intelligently route traffic to the instances based on your users' needs. We talked about virtual machines. There's a range of machine types. So you can go from 1 CPU to 64 CPUs. You can go from roughly half a gig of RAM to 416 gigabytes of RAM. And they've got a set of different combinations of resources. So they've got 4 pre-configured sets of recipes. There are standard, which is a nice blend or balance between CPU and memory. They've got high CPU recipes where that's like double the CPU for a given amount of memory. They have the inverse, which is high memory instances, and that's like double the amount of memory for a given amount of CPU. They've got shared CPUs, which are the least expensive and lowest performing VMs. And then if none of these pre-configured recipes work for you, you can make your own custom recipes and basically pick how much CPU and how much memory you want. For every VM that you start up, you're going to need attached storage. And so GCE offers standard and SSD persistent disks. Standard disks are rotating magnetic media, and SSDs are obviously really good for random I/O kind of operations. Disk options, whether they're SSD or persistent, offer you very high availability and durability. Your data is actually spread across multiple disks. So if a particular device goes down, your data does not get lost and you continue to have access. Your data is encrypted at rest, so Google automatically encrypts the data and manages the keys. If you work in an industry where you're required to manage your own keys, you can also provide your own keys and manage the encryption that way. They optimize your disk performance, so if you get like a 10 terabyte volume, that's actually probably a bunch of 100 gigabyte volumes, and your data is striped across that, so you don't have to do any software RAID configurations. And they have snapshots, which allow you to easily back up disks and make copies and then transport that backup maybe to other zones or other regions to spin up instances. Virtual machines range from 0.8 of a cent to $4 per instance hour. You only get charged while the machine is running. And there are a number of really customer-friendly pricing innovations. Instances are billed on a per minute basis. So for instance, if you use an instance for 11 minutes, even if it's a $4 an hour instance, you're only going to pay roughly 1/6 of that. You're only going to pay for the 11 minutes you use. There is a 10-minute minimum, but you don't pay for the whole hour, even if you only use a fraction of an hour. There are sustained use discounts. What this means is if you use an instance 24 hours a day, 7 days a week for the entire month, you'll actually get a 30% discount. The more you use it, the bigger the marginal discount becomes. They even go so far as to give you what are called inferred instances. So this is if you run one instance for 2 weeks and you run another instance for another 2 weeks, they'll actually stitch those two together and say, oh, you ran an instance for 4 weeks, and they'll give you the discount. And they also have this thing called preemptible instances, which is these are instances that you can get at a huge discount. They're 80% less expensive, so you only pay 20% of the price. But Google reserves the right to claw them back at any time. So what that means is if you have a compute load, for instance, where you need 10 VMs running, but you'd like 100, you can pay for 10 regular instances and 90 preemptible instances. And if for some reason they take back 20 or 30% of those instances, you still have a bunch of instances that were running at a vastly reduced cost. We showed you during the demo boot disk images, and there are 2 types of images. There are public images, and these are maintained by Google or third parties. And these are clean operating system boot images, so Debian, CoreOS, Ubuntu. There are also premium public images, so like Red Hat Enterprise Linux or SQL Server on Windows Server. These you have to pay an additional licensing fee on top of the VM instance fees. because you're using third-party licensable software. Generally what happens is you'll start with a public image and then you'll install your own software, you'll change the configuration, and then you'll save that as a custom image. And that's what we did in the example. So we use our custom front end and our custom back end images in order to create instance templates and then auto-scaling instance groups. So that is customizing a public image. You can also use the new Google VM migration service. This was just launched in the last couple of weeks, and it allows you to actually migrate live running VMs from other environments to GCP with no downtime. So check that out. Or you can also manually take, say, AWS virtual machines, export them as raw disk images, and then tweak them and import them into GCP, and then run those VMs now in Google Compute Engine. We had instance groups, and again, an instance group is simply a collection of machines that you can manage together as opposed to individually. So these allow you to easily add or remove instances. You can simply change the size of the instance group and it can spin up additional instances. Gives you self-healing on your instances. So if for some reason an instance goes down and you have a health check running, the instance group can determine that that instance is no longer healthy. It can shut it down and then bring up a replacement instance with the same configuration. We saw auto-scaling, and this can be based on CPU utilization. It can be based on requests per second if it's HTTP load balancing, or it can be based on custom stack driver metrics. So you can basically see how the machines are being used, and once they exceed an average utilization, you can add additional instances. This also scales down. So if you have 5 of those transcoding servers and then there's no more transcoding to do, after 10 minutes it will start backing off and shutting down instances. We saw load balancing, and we built an HTTP load balancer, which not only distributes the load across multiple backend instance groups, but it intelligently routes traffic to the nearest or fastest instance group as long as it has capacity. There's also TCP and UDP load balancing options available in GCE. And then these instance groups can be zonal or regional. So a zonal instance group is a set of instances that are all in the same sort of fault space. That means they're all in the same building in a data center. It's possible that that zone could go down. So power could go out or a network cable could go down. You can choose to make those instance groups regional instead. And if you do that, your instances are spread across multiple zones, which makes it less likely that if there's an outage in one zone, that's going to interrupt service to your end users. You have a sophisticated range of networking options available to you in Google Compute Engine. It automatically creates a network for you when you create a project. That network has a variety of subnets, and those subnets are all routed for you automatically. So it automatically generates these routes that allow all of these discrete subnets to talk to one another. You can also create custom routes as necessary. The firewall rules are super flexible, so basically you can say that instances with particular tabs allow incoming traffic, whereas instances without those tags don't allow incoming traffic. By default, there are a half dozen firewall rules created for you, but you can tweak those and add as many as you want. You have the ability to create VPNs so that your private IP ranges within your company are considered to be part of the GCP private address namespace, or the routing happens between the two of them, so you can easily work in an environment that bridges your GCP networks and your internal networks. Again, we talked about load balancing, and you also have Cloud DNS, which is GCP hosted public facing DNS if you wanted to do DNS on the cloud. In terms of managing all this, you saw me work primarily with the Cloud Console. So I did everything sort of manually. As it turns out, all work that you do in administering Google Compute Engine is done through a standard set of APIs. And when I'm using the console is talking to those APIs. I could also use a command line utility like gcloud or gsutil. Gcloud is for working with Compute Engine resources. gsutil is for working with Google Cloud Storage resources. All of these basically talk to the backend APIs. There are third-party utilities, or you can write your own custom scripts or applications to manage your resources as well. So the question is, given all of these capabilities, given the range of instance types, given the instance groups and load balancing and so forth, what use cases can you tackle and what could you do with Compute Engine? Here's one example for inspiration. Framestore is a company that does 3D renderings and video renderings. And basically, they use Compute Engine for excess burst rendering capacity. So they have a big render farm on site, but occasionally they need to have a whole bunch more cores thrown at a distributed rendering process. And so they work with Compute Engine, and they can spin up to 15,000 cores at the drop of a hat. This actually allows them to dramatically reduce their rendering time, and that allows them to do a ton of fast turnarounds. So they can actually be more creative as well as hit deadlines more easily, and they save money doing it, considerable amounts of money relative to having the same sort of capacity on site. This is a big example of the little example that we did with the transcoding on the back end of our LMS. Now, after today, when you start working with Compute Engine, you may need to go find answers to specific questions or guides on how to perform certain activities. So let me give you a few hints on where to look for additional information. Start with search. Search is your best friend. So if you start with GCP space and your topic of instance or interest, so for instance, GCP instance billing will give you a bunch of articles. The top 1 or 2 links will almost always be directly relevant and exactly what you want. If you're trying to figure out how to use the command line, always start with gcloud compute resource. So gcloud compute instances, gcloud compute instance groups, autoscalers. Whenever you want to manage one of those pieces using the command line, as I was using the UI, you would look for the gcloud compute command, and again, it will give you what you need. The documentation is actually pretty good. Typically, when you search, you're going to end up in some sort of a how-to guide or a quick start. But if you look at the breadcrumbs at the top of the article, you can actually go up to the top where you'll see a top-level table of contents. And this is relatively standard across all the products. So once you master this for GCE, for instance, you can use it for App Engine or Google Cloud Storage or whatever. So there will be quick starts, and this is a very short exercise that gets your hands dirty and gets you up and running on the technology. There are how-to guides. So this, for instance, would have guides on how do you build an autoscaler? How do you create an image? How do you create an instance group? How do you create a load balancer? And then there are deep dives into APIs and concepts and so forth. A few notes on how to best evaluate how well Compute Engine will serve your needs for particular use cases in your environment. So the first thing to consider is when you're trying to make a decision about applying a new technology to business opportunities, you want to take it seriously. It's not hard, but have a process and follow the process. Typically, what we recommend to people is that you start by defining some decision criteria. What is it that you need to know in order to make a decision that, yes, this technology will work for you? So for instance, does it scale to meet our company's usage needs? Is it easy to configure? Can our existing systems operational professionals get up to speed within a couple of days? Once you've decided what it is you need to know, then you figure out how to test. So you're going to take an existing use case, and generally you're going to create a minimum viable product that emulates either something you're already doing or something that you hope to do. And once you have figured out how to test, so what is it you're going to build, then you do some research to figure out exactly how to architect that on the platform. Then you're going to actually go ahead and build it. You also need to decide who's going to be on the team, and they're key players. You need to have somebody who's going to be responsible for the architecture of the application. So for instance, are you using Cloud SQL as part of the solution? How are you going to do load balancing? Where are you going to locate servers? You need some operations people. These are the people who are going to actually be standing up the instances and managing the configuration. You need somebody who's going to be responsible for program managing and then reporting out the results. And then obviously you need somebody in the business side of things to help with the decision making. Typically, we find like 1 month per use case is a pretty good time period. So in the first week, you do your defining of the criteria, you recruit your team, and you agree on what you're going to test. In weeks 2 and 3, you define your architecture and you actually perform some pre-testing to make sure that you understand how all the pieces work and you're doing things right. And then in the last week, you actually perform the test, consolidate the results, and you make a decision. Now, obviously, this timeline will change depending on the complexity of your use cases, as well as the investment that you've put in terms of how many people are on the team. This could be longer or shorter, but 2 to 3 month trial period will give you the opportunity to test a couple of different use cases and make a really intelligent decision about how to apply GCE to your particular use cases. So hopefully that gives you a good sense of how to go about evaluating Google Compute Engine for specific use cases in your environment. And that's all for this session. Thanks for joining us. We'll be sending you an email that has a link to CodeLab, which allows you to try out on your own some of the concepts that we covered during this session. We'd also love to get your feedback, so provide that feedback on screen and stay tuned for our next session.